another video in the grade 7 to 9 GCSE Maths series. In this video, my focus is on applications of surds, how we can use and implement skills such as rationalising and simplifying surds within context to problem-solving questions. So let's start with question number 1. We're told that ABD is a right-angled triangle. All measurements are given in centimetres, and we're told that C is the point on BD such that the length of CD is √3/3. We're also told that length AD and BD are equal, and the size of those is √2/2. Now, they have given that on length AD, but they haven't drawn it on length BD. So let's pop that information onto the diagram, √2/2. And we've been asked to work out the exact area of the shaded region. So that can be found by looking at the area of the big triangle and subtracting the area of the smaller triangle that's sitting inside of it. So let's first of all work on the big triangle, triangle ABD. So we're going to use the formula for area of a triangle, which is half the base times the height. So we're going to do 1/2 times √2/2 times √2/2. So we get √2 times √2, which is 2, and 2 times 4 times another 2 is 8. So that simplifies to 1/4 centimetres squared, the area of the larger triangle. Next, what we need to do is to work out the area of the triangle that's sitting inside of it. So let's shade that in a different colour, into green. And let's work out the area of that triangle using the same formula, of course, half the base times the height. So 1/2 times √2/2 multiplied by √3/3. Multiply the numerators, we get √2 times √3, which is √6. And then the denominators, 2 times 2, 4 times 3 is 12. So we get √6/12 centimetres squared for the area of the smaller triangle. We've got everything we need now to work out the area of the shaded region. We're going to take the 1/4 centimetres squared and subtract the √6/12. And before we can subtract those fractions, we do need a common denominator, which is 12. So the 1/4 becomes 3/12. And we take away √6/12. Now we can subtract those fractions and we get 3 minus √6/12 centimetres squared. And that is the exact area of the shaded region. Moving on to our second question. It has its similarities to the previous question, but this one involves more complex surd expressions on the sides of the triangle. So let's take a look. All measurements on the triangle are in centimetres. ABC is a right-angled triangle and K is a positive integer, and we've been asked to find the value of K. Now we do have 2 of the dimensions given, albeit in surd form, but that does mean that we can use Pythagoras' theory to work out the third dimension. So this question involves Pythagoras, and the theory states that a² plus b² equals c². Now that's for any right-angled triangle, the relationship between the 3 lengths. Let's highlight on the diagram what is length A, what is length B and C. Now it can get a bit confusing when they have labelled the vertices of the triangle with those same letters, but you've just got to ignore those and remember that A and B, they're the 2 sides of the right-angled triangle that meet at the right angle. So they're A and B. And length C is the longest side of the triangle, and that never actually touches the right angle, it's opposite it. So that's length C. Now we've allocated the lengths correctly, we're now going to substitute. So we're going to replace A with K. So we need to do K². We need to replace B with 3 plus root 5. And we need to square that. And we need to replace c with root 3 plus root 15. We need to square that as well. Now, how do we square a bracket? Well, if we think about what squaring actually means, it's to times something by itself. So we're going to times the bracket by itself. To do that, we're going to write it out twice. And then we'll use the standard FOIL method to expand the brackets. Do the same on the right-hand side. We need to square that bracket. So that means we need to times it by itself. As mentioned, we're going to use the standard FOIL method to multiply out the brackets. So let's begin. So we've got the k squared. Let's bring that down. Don't forget about him. And then we're going to do we're going to do 3 times 3 first of all, which is 9. Then we're going to do 3 times root 5, which is 3 root 5. Then we're going to do root 5 times 3, which is another 3 root 5. And finally, root 5 times root 5 is 5. Coming to the right-hand side, root 3 times root 3 is 3. Root 3 times root 15 is root 45. Root 15 times another root 3 is another root 45. And root 15 times root 15 is 15. So we've done all that lovely expansion. Now we're going to begin to simplify. On the left, we've got 9 plus 5. So let's simplify that. We've got k squared plus 14. And sometimes students get a little bit muddled when adding surds together. You can add like terms together. So if I asked you what 3x plus 3x was, you would tell me it's 6x. And that's the same we can do with these surds. They're like terms. So 3 root 5 plus 3 root 5 is 6 root 5. On the right-hand side, we've got 3 plus 15, which is 18. And I've got some like terms again here. I've got root 45 plus another root 45. So I've got 2 of them, 2 root 45. Now at this stage, I am going to try and simplify the root 45. And I'm going to write it as root 9 times root 5. Chosen 9 because 9 is the square number. So there's my root 45, the root 9 times root 5, and I've got 2 of them. Let's simplify that a little bit more. So root 9 is 3, 3 times 2 is 6, so we have 6 root 5. And over on the left, we've still got the k squared plus 14 plus 6 root 5. Now we need to try and balance the equation to make k the subject. And note that we've got a 6 root 5 and another 6 root 5 on both sides of the equation. So we can effectively remove them, take away 6 root 5 from each side of the equation. Next, we're going to remove the 14, take it away on the left, balance it up and take it away on the right as well. So now we're left with k squared on the left, and that's equal to 4 on the right. And we're ready to get our value of k. We're going to square root 4, and we're told that k is a positive integer. So if we square root 4, we get 2 as our answer. So k equals 2 centimetres. So here we come to our final question of the video on application of surds, and that takes us to a question involving a solid cylinder. We're told that the cylinder has a radius of 4 root 3 and a height of 8 centimetres, and the total surface area of the cylinder is this lovely looking number here, 56 pi root 6. We have to find the exact value of h and give our answer in the form a root 2 plus b root 3, where a and b are integers. So we've got an idea what our answer needs to look like, but where do we begin to start with this sort of question? Well, we're going to have a look at this sentence here. The total surface area of the cylinder is 56 pi root 6. So how did they get that answer? Well, let's begin to work out or write down the formula for the total surface area of a cylinder. So to get that total surface area, we need to work out the curved surface area. And we also need to add the circular top and the circular base. Okay, so curved surface area, how would they have worked that out? Well, the curved surface area, imagine this is a can of baked beans and you've got a label wrapped all the way around it, which creates the curved surface area. Now imagine peeling off that label and laying the label out onto your kitchen counter, and the shape you're going to see is a rectangle. The height of the rectangle will be the height of the cylinder. So let's put H on there. And the length of the rectangle is this distance, the circumference of the circle. And we find circumference by doing pi times the diameter. Now we can easily find the diameter because the radius has been given. And if the radius is 4 root 3, the diameter is double the radius. So double 4 root 3, we get 8 root 3. So now we can say that the circumference is going to be pi times the diameter. So pi multiplied by 8 root 3. Let's just tidy that up a little bit and write that as 8 pi root 3. So we can replace that now for the length of the rectangle. It's 8 pi root 3. So the area of the rectangle will be 8 pi root 3 multiplied by h. So now we've got an expression for the curved surface area. We can put that in here. 8 pi root 3 times h. Next is the area of the circular top and base. So area of a circle is using the formula pi r squared. So we're going to multiply pi with 4 root 3 times 4 root 3 again. 4 times 4 is 16. Root 3 times root 3 is 3. And then don't forget to times that by pi. So we get 48 pi. But don't forget, we've also got the circular base as well. So we will need to double that answer. So the total area of the top and the base is 96 pi. Now we can also fill in the numerical value for the total surface area. It's the 56 pi root 6. So let's write that in here, 56 pi root 6. And let's just briefly go over what we've done here. So we were told the numerical value for the total surface area was 56 pi root 6. We knew that to find the total surface area of a cylinder, we needed to work out the curved surface area, which is essentially the same as this rectangle, the label peeled off. And finally, we also needed the area of the circular top and the circular base, which we found to be 96 pi. So now we have got the task of trying to rearrange this and making h the subject, and hopefully making it look like in the form a root 2 plus b root 3. Now, the first thing that I like to do with an equation is just to see if we can simplify it. Can we scale the equation down? And hopefully you can see that each of these 3 terms, they're all divisible by 8 pi. So if we divide each of them by 8 pi, the equation is going to look a lot easier for us to deal with. So these pi's will cancel out. 56 divided by 8 is 7, so we have 7 root 6. The 8 pi and the 8 pi cancel, so we're left with root 3h. And then finally, pi divided by pi cancels, and 96 divided by 8 is 12. So look at how much better that equation looks already. So we now need to rearrange and make h the subject. So let's begin to do our rearranging method over here at the top of the page. So we have 7 root 6 equals root 3 times h plus 12. So the first thing we're going to do is to remove 12, take 12 away from each side. So we'll have 7 root 6 take away 12 is equal to root 3h. And then to get h, all we need to do is divide by root 3. And obviously balance it out. So whatever you do to the one side, do to the other. These root 3's cancel. So now we have got a value for h. It's 7 root 6 take away 12 over root 3. Now that's a valid answer for h. However, we are instructed that we have to give our answer in the form a root 2 plus b root 3. Ours doesn't look like that at the moment, but what you'll notice is that we have a surd on the denominator. So we're going to rationalise this fraction so that we don't have that surd there. So that's our next step. So let's show our method for rationalising the denominator. We're going to need to multiply the denominator by root 3 to get rid of the surd, and that means we'll have to do the same to the top and times by root 3 to keep our fraction equivalent. So multiplying the top, we're going to need a bracket, and multiplying the numerator, root 3 times root 3. Okay, so root 3 times 7 root 6. Root 3 times root 6 is root 18. So we have 7 root 18, take away root 3 times 12. So take away 12 root 3, and that's over 3. Root 3 times root 3, 3. Still not looking quite how they want it. So let's keep going, noting that root 18 can be simplified, because there is a square number that goes into 18, and that's 9. So we can express the root of 18 as the root of 9 times the root of 2. Still subtract 12 root 3 over 3. Root of 9 is 3. 3 times 7 is 21. So we have 21 root 2. Take away 12 root 3 over 3. And we are almost there for our final answer. We're going to divide everything on the numerator by 3. So 21 over 3 is 7. So we have 7 root 2. And 12 divided by 3 is 4. So we have minus 4 root 3. So there we have it. We've got our final answer. They wanted it in the form a root 2 plus b root 3. Which we have. So 7 minus root 2, 7 root 2 minus 4 root 3. Hope that you've enjoyed today's videos and that you found them useful. If you've got any comments, please comment down below. And if you've got any more topics that you would like me to go through, please also put those in the comments, and I'll be happy to make some extra videos.